In this lecture, we'll have a look at linear trend lines with no intercept. No intercept is just sort of a weird way of saying that the intercept is zero, meaning that we have a trend line that intersects the origin. So my trend line now will look like this. The intercept is zero and it still has a slope such that when x increases by 1 unit, the trend line increases by b2 units. The equation of the trend line will now be y is equal to b2 times x. Compare that to the general linear trend line with an intercept, which is given by y is equal to b1 plus b2 times x. So the first question is then, why would you like to force the intercept to be zero? Well, the answer is that you could have a theoretical argument for that. Here is a simple example. I have 9 observations, and in this example, I drop an object from different heights. I measure the time it takes for this object to reach the ground, and I measure the velocity of the object as it hits the ground. So the first object fell for about 0.4 seconds, and when it hit the ground, it had a velocity of 4.2 meters per second. This one, the third one, was dropped from the highest altitude. It fell for 2.1 seconds, and it reached the velocity of almost 21 meters per second. So if I make a scatter plot of this, and I add a trend line to it like this, and I also display the equation on the chart, I will have a slope of 9.8 and an intercept of 0.28 approximately. So if you think about the intercept in this case, that would be the value of y when x was 0. X equal to 0, that represents a case where the object has not fallen at all. It has fallen for 0 seconds. So that means that the velocity in that case must be 0. I drop it, and if it has no chance to fall, it has no chance to speed up. So this is a case where I might want to force the intercept to be 0. You can actually do that in Excel by just formatting the trend line, and there is an option here where you can set the intercept to be a particular number. So if you set the intercept to 0, that's the case which we call that the trend line has no intercept. If we do that and remove and display the equation again, we get a new trend line, which is just y equal to 10x with no intercept. So what we will investigate now is how this number 10 is calculated. How do you calculate the slope of a linear trend line if you have forced the intercept to be 0? Well, the answer is that we calculate the slope in this case from the same principle, namely the least squares principle. It's just that the residuals and the fitted values will be slightly different in this case. So if you have a trend line with no intercept, B1 is 0, then the fitted values, which usually when we have a trend line with intercept is defined as B1 plus B2x, well, that's now going to be defined as just B2 times x, simply because we have forced the intercept B1 to be 0. The residuals are always defined as yi minus yi hat, So the residuals will now be yi minus b2 times xi. So in this case, the residuals will only depend on b2, not b2 and b1. We apply exactly the same principle, namely we pick b2 such that RSS is as small as possible. So we have the same principle, minimize RSS, just remembering that in this case RSS just depend on one variable, b2. And if we perform this mathematical problem, solve the least square problem in this case, which is actually a little bit simpler than the general case with an intercept, we get the no intercept OLS formula for B2, which looks similar but definitely not the same as the OLS formula for B2 when we include an intercept. We can check that this formula for the OLS without intercept is correct and compare them. The B2 with an intercept, remember, that was calculated using the sample covariance between x and y, covariance sample x and y, divide that by the sample variance of x. So variance dot get this to work. Variance of the x variable, and we need var dot s. So that's the formula for B2 with intercept, 9.8, the way we saw before. To do the B2 without intercept, we need a new column where we multiply x and y. So if I just do equal to the x value multiplied by the y value and sum this down, then the formula for B2 without an intercept is the sum xi yi, so it's the sum of all these highlighted numbers divided by the sum of xi squared. So I can just do sum of all these numbers divided by the sum of squares of the x's. Like that, and that should give me 10 if we've done this correctly. If you put the OLS formula for B2 with and without intercept next to each other, you see that the difference is that in the formula with intercept, we always subtract the sample mean of each observation before computing this ratio, while we do not remove the sample mean in the formula for B2 when we have no intercepts.